Okay guys, today we're going over 6-8 parallel and perpendicular lines. Here are the objectives. We want to jot those down. Just as a quick reference, for perpendicular we're using the upside down T. For parallel we're using the double L or the train tracks. Okay? Alrighty, the slope and y-intercepts of a parallel and perpendicular line have perpendicular characteristics. Okay, to see if any two lines are parallel, first you have to find the slope and check the y-intercepts for each line. Okay? And again, I would use the reference on page 170 to see those graphs on that first page. Okay? If the two lines have the same slope but different y-intercepts, then they are parallel lines. So for instance, if you had, let's do y equals 2 over 3x plus 1, and y equals 2 over 3x minus 9, or plus 9, we'll do plus 9. Okay? These two lines would be parallel lines because they have the same exact slope, they have a different y-intercept. Alright? To check if two lines are perpendicular, check out the slopes. If the slopes are negative reciprocals, then the lines are perpendicular. Okay? Just as a reminder, negative reciprocals are numbers whose product is 1. So for instance, 1/2 will be a negative reciprocal of negative 2, which is negative 2 over 1. And then, like negative 3/4, or negative 3 over 4 is a negative reciprocal of 4 over 3. You guys are so smart. Super duper smarties. Okay? So all you do is flip the top and bottom numbers and slap a negative on it. If it's already negative, make it a positive. Okay? If you put these two together, if you multiplied negative 3/4 and positive 4/3 together, that would give you negative 1, 1, 1, 1. Negative 1 times a positive 1 is negative 1. Okay? So that's what the light blue statement refers to. Okay? So your slopes have to be negative reciprocals. Alrighty? You can check if lines are parallel or perpendicular either on a graph or in a linear equation. But remember, in order to compare accurately, the equations have to be in the same form. Okay? So right now I want you to write an equation of the line with a y-intercept of negative 2 that is parallel to the line y equals negative 5x plus 3. Okay? So take a moment, pause the video, then hit play, and we'll see if you're correct. Okay guys, we got y equals negative 5x minus 2. This is the parallel line to y equals negative 5x plus 3. You are correct. Okay? All you do is you plug in the negative 2 for your new y-intercept, and your slope is automatically the same because you're looking for a parallel line. Remember, parallel lines have the exact same slope. Okay? Alrighty. I want you to write an equation of a line in slope-intercept form, remember, which is y equals mx plus b. M equals your slope, b is your y-intercept. That passes through the point negative 16, negative 1, and is perpendicular to the graph 8x plus y equals negative 6. Okay, again, so they're asking for it in slope-intercept form. Okay, erase that. Okay, so right here you have to ask yourself, is 8x plus y equals negative 6 in slope-intercept form? You'd be so smart, because that is not. So let's just erase this bad boy. Let's rewrite this in slope-intercept form. So we have 8x plus y equals negative 6. So let's subtract 8x on both sides. Okay. To get y equals negative 8 minus 6. So that's your new slope-intercept form. Okay. So now we're going to use this point right here, which is negative 16, comma 1. Remember, negative 16 is your x, negative 1 is your y value. Okay, so you're just going to plug in those values into your slope-intercept form. Okay? So let's do that y is negative 1, so we're going to negative 1 equals. Okay? Now remember, you're wanting a perpendicular line, so you're going to want to use the negative reciprocal of negative 8, which is a positive 1 over 8. So let's put that one in here. Okay, multiply that by your x, which is negative 16. Back to red here. Okay? And then plus b. So I don't know what your b is going to be quite yet. That's how you're going to figure out this. So this is how you figure out what your new y-intercept is for this perpendicular line that is passing through point negative 16, negative 1. Okay, so let's do this. So we have negative 1 equals, let's put this one over 1. Okay, we're going to simplify. Okay, so that is going to give us negative 2 over here plus b. Let's add 2 on both sides. Okay, so we're going to get we're going to get a positive 1. So that's going to equal, so b is going to be a positive 1. Okay? Okay, so we just found out what our new y-intercept is going to be. So let's plug this in. So our new perpendicular line to this right here is going to be a positive 1 over 8x plus 1. So this is your perpendicular line to this original line right here. Remember, you had to put that in slope-intercept form. You can't compare forms if they're not in the same form. Okay. Alrighty, now are the graphs of these two equations on either side, perpendicular, parallel, or neither. Okay. So I want you to pause the video and see if you can solve these. Use your book and your notes if you need to. Okay. Okay, guys. So if you got this first equation right here is parallel, that's correct. They have the exact same slope, 2 over 1, and then their y-intercepts are different. 1 and negative 1. Okay, over here, this is our first equation, so y equals negative 1 over 2x minus 1. When you simplified and got it into slope-intercept form, we got y equals 1 over 2x plus 1/3. So they are reciprocals, 1/2. They're the exact same, except one is positive and one's negative. So they can't have the same slope, and it's going to be neither. Okay? All right. So what I want you to do right now is to do number 4 and 5 in the try these. Okay? See if you can figure them out, and then we'll work on the rest tomorrow in class. Okay, guys, good luck. Bye.